Okay, so we've got to find the volume obtained by rotating this region here. I've already got it illustrated. Just trying to save time. So of course you plug into y equals, this is like the standard graph, and then you can just zoom in a little bit. If maybe you want to do the algebra ahead of time, it could in theory help you set parameters. But this is what I got. So this region here, it's bound by those two curves, is being rotated about the x-axis. So set it up. And it turns out you actually could do this with shells or with washers, right? Because shells is fine. You can define that distance. You can also define this distance. So it turns out it doesn't actually matter as far as which method you use, other than what expressions you want to work with. Now I'm going to say maybe it's better not to introduce a radical, right? Like we could just leave it, instead of solving for x, we could just leave it. We've got y's expressed in terms of x. So we can work with the x's, or I say the y's in terms of x. So if we're going to be working with expressions of x, we would want to use washers, because remember when you're doing discs, washers, discs, you want to draw your strip orthogonal or perpendicular to the axis of rotation, right, at 90-degree angle. So this distance here would be defined by with the functions, but the width itself is partitioned the x-axis, right? So when we go ahead and do a washer, because this region will be hollow in the middle, we got dx as our width, and now we can just work with the y's in terms of x. So when we go ahead and try to define the volume of this piece, right, we know we've got the width, we need the area of the surface, so we start with the outer radius. Well, the outer radius is the red function, right? Extends all the way out to the line. So we're talking the upper y, which is this piece here, which in terms of x is 3x. So we got 3x. So I'm going to get the pi in there too. So we got pi, and then the radius squared, well, the radius is the 3x, minus the lower y is just y equals 0, right? Because the axis of rotation is just y equals 0. So squared dx less the inner piece here, the inner, you can think of it as a inside disk, right? That's what makes this a washer. That's going to be pi, and its radius extends to the blue function, which is 3x to the 6th, and then that's squared, and then we got another dx, right? Okay. So this here is, the expression for one of those washers, the volume of one of those washers. All right, and then I just got to move this, because this was the strip. All right, and I'll do that, and that was right there. That's the strip. Okay, so now we just need some limits of integration. So the way to do that, of course, is we don't know. I mean, set up, there's a 0 there, starts at 0, but look, we're just setting this equal. 3x to the 6th equals 3x. And, let's go ahead and, we already consider the solution x equals 0, right? X can be 0, but you gotta be careful dividing by a variable is what I mean to say sometimes. But when x is 0, we have a solution, right? X is 0 is certainly a solution. If you divide both sides by x, we're talking 3x to the 5th. Did I say 3x? Let's divide both sides by 3x, if I didn't say that. If you divide both sides by 3x, we're talking x to the 5th equals 1, right? So the only solution to that, of course, is the 5th root of 1, which is 1, right? So x is 1. So this is the x value of 1, so we're going from 0 to 1. All right. So now it's just a matter of setting up our definite integral. We're going from 0 to 1. We've got a pi that's common. We also, if you notice, have a 9 that's common. I'm going to pull out 9 pi, right? Because in both cases there's a radius of, there's a 3 coefficient in the radius. I think it's squared to become a 9. So that leaves, we've got x squared minus, this is going to be x to the 12th dx. Right? And then it's just a matter of, well, now you can, it's nice to pull out the pi because it'll help you get the exact answer if need be. But we'll do this by hand. Exact answer using the calculator. I mean, let's see, we've got 9 pi times, this will be x cubed over 3 minus x to the 13th over 13 from 0 to 1. And let's see, we get 1/3 minus 1/13. And plug in 0, you get 0. So that'll be 39. So we're talking 13/39 minus 3/39 is 10/39. Okay, so we're talking 9 times 10 is 90 pi over 39. I'm sure I missed a common factor of 3 there. I did. So we're talking 30 pi over 13 should be the answer. Okay, hopefully that helps, and take care.